Hey guys, this is Pre-Algebra lesson 5-6, add expressions. In this lesson, we'll be able to add expressions that represent real-world problems. Let's start with solve and discuss a question. The Smith family took a 2-day road trip. On the second day, they drove 3/4 the distance they traveled on the first day. What is a possible distance they could have traveled over the 2 days? Is there more than one possible distance? Justify your response. So, what do we know and what do we not know? On the second day, they drove 3/4 the distance they traveled on the first day. So did they travel more on the second day or more on the first day? 3/4 is 75%. So they traveled more on the first day. Do you know how many miles they traveled on the first day? No, they don't tell you. So that could be a variable, right? So think about how the quantities in the problem are related. So we have the distance in miles and what else? The distance in miles on the first day versus the second day and the total distance they traveled, right? So you can write, how can you write an expression for that? You can say X could represent the distance they traveled on the first day. Because that's unknown. That could be a variable. Okay, so then total distance is the distance they traveled on the first day, X, plus the distance they traveled on the second day, according to X. In terms of X, how can we write the term for the second day? 3/4 times X would be the total distance they traveled on the second day, right? First day, and that's second day. Which, if you simplify like terms, would be what? 1 plus 3/4 would be 1 3/4 X or 7/4 X. Okay, so what is one possible distance they could have traveled over the 2 days? So the total of 2 days. You can just pick a number. What if they traveled, how many miles is a good mile? 1 mile is not much. So you need to be more practical than just 1 mile. Because 1 mile, you can just run. If they're traveling, they're probably traveling a lot more than what you can walk in a day, right? So with a car, let's say maybe 300 could be the distance they traveled on the first day. So 7, let me erase that. So total distance they travel could be 7/4 times 300, which is 525 miles. So total distance they could have traveled could be 525 miles if they traveled 300 miles on the first day. So they could have traveled 525 miles if they traveled 300 miles on the first day. Okay. The last question. Is there more than one possible distance? Yes, because why? We don't know how many miles they traveled on the first day. It could be 300, it could be 325, it could be 200, it could be 400. You don't know. So it depends on the first day, and you don't know that. So there could be many possible ways. Okay, so let's write that down. Okay, we just don't know. Focus on math practices. How can two different expressions be used to represent the total distance? We have one expression here, right? We can say x plus 3/4 x could be 1. And we can say we have to explain. So x plus 3/4 x could be simplified to 7/4x. Okay. All right, let's look at example 1. How can properties of operations be used to add expressions? Let's add the whole expressions. We've already learned how to add like terms in one expression. What if we have two different expressions, three different expressions all together? So we're gonna remember the properties that we learned for adding like terms and add some expressions. Let's look at example 1. Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after n months? Let's see what they have. Rudy's climbers have initial fee of $65 and $40 monthly fee. Okay, and then Ace Health Club will have initial fee of $80 and $50 of monthly fee. So she's going to both, and she's paying for both every month. That's a lot of money, actually. But yeah, what represents the total number of money, the total pay that she's paying every month? So you can write two different expressions and combine them both to find the total payment she's paying for both of them. You can use two bar diagrams as well to visualize it. 80 initial fee and 65 initial fee don't change. You pay $80 and $65 whenever you start. And then every month you pay $50 and $40 every month. So that could be multiplied by n months. So add the expressions together. 80 plus 50m plus 65 plus 40m. You can combine like terms and get 145 plus 90m. Okay, so simplified expression can help you figure out calculations quickly. So look at try a question over here. Sophia and Oli each deposit $120 to open a joint account. So they're gonna start with the same dollars. They each make monthly deposits as shown. They're gonna put in money into their bank account, but they have different rates every month. What expression represents the amount in the account after n months? Sophia will save $150 every month. Oli will save $135 every month. So after n months, what expression could represent their total deposit? Okay, so first write expressions for Sophia's deposits and Oli's deposits, combine like terms and simplify like terms. See if you can do it by yourself and come back when you're ready for answers. Okay, Sophia's deposit, you start with 120 and add 150m every month, right? Oli's will be 120 plus 135m. Okay, so adding like terms, 120 plus 120 and 150m plus 135m. Okay, you can group the like terms together. You don't need to have parentheses, but add the like terms and you'll get 240 plus 285m. And that's it. You don't have to have a numerical answer. This is your answer for this problem. Okay. The amount of money in the joint account after n months is 240 plus 285m. You don't know how many months, so m is just m. Okay. Convince me. Explain why the initial deposits and monthly deposits are not combined into one term. Why can you not combine these two numbers and say, oh, could that be 525 or 525M? Are they like terms? No. So the total deposit amount for the variable term changes as the month changes, but the initial deposit doesn't change with the number of months. So it's not going to be affected. Okay. Initial deposit, they already paid. So like they're already put in. It's not going to change. Never changes. So they're not like terms. You cannot add them together. Let's write that down. Here you go. Okay, they are not like terms. All right, example 2, adding expressions with more than one variable. Cindy spent $125 on ingredients for muffins and $92.4 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So you can first find the expression for the muffin. So the muffin income would be $2.4 per every muffin, but the cost of ingredients would be $125 for muffins. And so you need to subtract it because you buy the ingredients. So you spend the money first, and then you earn money by selling it. So you have to subtract it later to calculate how much earning she really had. Same for bagel. You earn 1.8 times how many bagels she sells, and then she needs to subtract the cost of ingredients, $92.4. So you can use commutative and associative properties by adding them and combining like terms and get the expression 2.4M plus 1.8B minus 217.4 to represent the profit from selling the muffins and bagels. So now your expression is longer with two different variables. That's okay because they represent different numbers, right? M is for number of muffins sold. B is for number of bagels sold. They're going to be different numbers. So you need to give different variables for the unknown things. Okay. Example 3, adding more complex expressions. You're going to add the expressions algebraically. So look at them and see if you can simplify anything in the parentheses. They're all unlike terms, so don't worry about the parentheses. Group the like terms using commutative and associative property. Put the x terms together and the y terms together and the constants together, and you can subtract the like terms, and that should be your equivalent expression. Okay, so see if you can do it by yourself. Try finding each sum for A, B, C, and D. Use commutative and associative property to reorder and group like terms and see if you can simplify them. Come back when you're ready for answers. Okay, part A. So grouping like terms. You have C term just by itself and P term just by itself. You just have the constants to be able to add, right? So 9.74C just stays the same. And that plus negative becomes just minus 5.48P. And then you add the like terms, 185.7 minus 250.5 is negative 64.8. So that is your most simplified expression. You cannot simplify further. That's it. They're all unlike terms, so you cannot add them. Okay, stop here. Okay, part B. Group the like terms together, the x terms together, y terms together, and the constants together. So 211x, and then make sure you have negative when you're moving things, minus 3 over 11x. Okay, these are together. And then group the y terms together. And you can add negative 5y plus 5y. So they're going to cancel each other out. And you can add negative 3 plus 5.5. And then you have negative 1 over 11x. Y is canceled out. You have 0 y, so it's just 0. You don't even need to write it down, okay? And then negative 3 plus 5.5 is 2.5, positive 2.5. Okay, that's it. Part C, do the same thing, negative 14.2b plus 6.76d. I'm not going to bother with the parentheses now. Minus 3.4d, and then you have minus 97.35 minus 118.7. And so adding the d's together, d terms together. Wait, this is b. So b is just b, negative 14.2b. B. Just be careful. B and D look similar. All right, you can add the D terms together now. Adding them together, you should get 3.36D. And adding the constant terms together, you should get negative 216.05. And that is the end. You should stop there. Okay, what about fractions? Same thing, group them together. Negative 1 over 6m plus 7 over 10m. And then you have 5t plus 9t. And then 3 over 8 plus 1 over 4. And then you have to match the denominator. Okay, and you can say, oh, negative 1 over 6 plus 7 over 10 could be 60, right? Negative 10 plus 7 times 6, 42. So that's going to be 32 over 60, which is 16 over 30, which is 8 over 15. So 8 over 15m plus 14t plus 5 over 8 is the answer, the final answer. Okay. Did you get everything right? If you did, good job. If you need more practice, there are practice problems. Make sure you go over it before the lesson quiz. Let's look at key concept and summarize it. Adding expressions when you require combining like terms. So when you add expressions or when you simplify expressions, you have to add like terms, combine like terms. If you have more than 2 variables, more than 1 variable, make sure the variable terms are the same. And if they're not like terms. So combine what you can leave as you can leave whatever is not like terms as it is. And that could be your answer. All right, that was lesson 5-6, adding expressions. We'll continue with the next lesson, lesson 7, subtracting expressions. It's going to be very similar in the next video. All right, guys, good job. Bye.